Hello dear students. In this video, we will have a look at some basic concepts related with lines and angles. The following are our learning objectives for the day. First, we will recapitulate the basic concepts related with lines and angles, and then we will prove that vertically opposite angles are equal to each other. To start with, let's have a look at some basic definitions. First, we will define a line. Mathematically, a line can be defined as a straight one-dimensional figure having no thickness and extending infinitely in both directions. That means a line will not have an endpoint in either of the direction. Let us consider a line AB. And as you can see here, between A and B, there are no markings which suggests an endpoint. So that means this line AB can be stretched on either end infinitely. So a line will not have a fixed length. So this line AB can be stretched further on the right and on the left as well, like this. So a line will never have a fixed length. This line AB can be stretched further as well. On the contrary, we have line segment. Line segment is a part of a line with two endpoints. So on a line segment, we will have endpoints. So as you can see in this figure, there are markings which suggests endpoint in both the directions, at A and at B. So a line segment will have a fixed length, on contrary to a line which will not have a fixed length. Next, we will define ray. Mathematically, a part of a line with one endpoint is called a ray. So in a ray, we will have endpoint at one end, whereas the other end can be extended infinitely. So a ray can be said to be a mixture or hybrid of both line and line segments, where it has characteristics of both line and line segment. Here, OA is denoting a ray. As we can see on the left hand side where we have O, we don't have an arrow. It suggests that O is a fixed point and it cannot be extended further. Whereas on the right hand side where we have A, we have an arrow. That means it can be extended towards the right. Next, we will define angle. So an angle is formed when two rays originate from a common endpoint. So if two rays originate from a common endpoint, we will get an angle. So let us assume OA to be the first ray and OB to be the second ray originating from the same endpoint O, from the same or common endpoint O. So here we have got an angle where OA and OB are the arms of the angle. So we can name this angle as angle AOB or angle BOA, where O is the vertex of the angle. Vertex can be defined as the common endpoint of an angle. Now we will have a look at different types of angles. First, we'll start with acute angle. Acute angle is an angle which measures more than 0 degree but less than 90 degree. So right here, this represents a right angle or 90 degree. So an acute angle should measure less than that. So this is an representation of acute angle. Let's consider one more representation, 90 degree, less than that. So the range of acute angle is between 0 and 90 degree. X should be greater than 0 degree but less than 90 degree, considering X to be an acute angle. Next, we have right angle, an angle which measures exactly 90 degree. So our right angle is represented with this symbol. So this suggests that the measurement is exactly 90 degree. Next, we have obtuse angle. So obtuse angle is an angle which measures more than 90 degree right angle but less than 180 degree, which we call as straight angle. So obtuse angle looks like this. One more representation. So the range of obtuse angle is between 90 degree and 180 degree. Considering X to be an obtuse angle, X should be greater than 90 degree but less than 180 degree. Now, straight angle, an angle which measures exactly 180 degree. Representation of a straight angle. So straight angle is represented by a straight line. So straight line measures 180 degree. Next, we have reflex angle, an angle which measures more than 180 degree but less than 360 degree. So representation, considering T to be an angle, the angle T dash at the other end is known as its reflex. So if T is the angle here in this representation, then T dash will be its reflex angle. We can calculate reflex angle using this formula. Considering T to be the angle, the reflex angle T dash will be equal to 360 degree minus T. The range of reflex angle is between a straight angle and a complete angle. That means a reflex angle will be greater than 180 degree but less than 360 degree. Now finally, complete angle, an angle which measures exactly 360 degree, one complete rotation, starting from the same point, rotating and going back to the same point. It represents a complete angle and its magnitude will be 360 degree. Now, adjacent angles. Two angles are said to be adjacent if they have a common vertex, a common arm, and their non-common arms are on different sides of the common arm. In order to understand this, let's consider a representation. Here, in this figure, angle ABD and angle CBD are adjacent angles as they have a common vertex B. B is the common vertex for both the angles, angle ABD and angle CBD. A common arm, BD is the common arm, and the non-common arms BC and BA are on different sides of the common arm BD. BC is on the right of BD and BA is towards the left of the common arm BD. Now, linear pair. When the sum of two adjacent angles is 180 degree, then they are called a linear pair of angles. This property is very important and we will be using this property to solve various questions. In this representation, angle AOC and angle BOC will form a linear pair of angles, as the addition of the two angles will give us a straight angle, angle AOB. So here we will have angle AOC plus angle BOC equals to 180 degree as the sum of the linear pair of angles. Next, we will define vertically opposite angles. The vertically opposite angles are formed when two lines intersect each other at a point. In this figure, line AB and line CD are intersecting at point O to give us two pairs of vertically opposite angles. The first pair is angle AOD and angle BOC, and the second pair of vertically opposite angles are angle AOC and angle BOD. In order to name the angles, we can use the name of the points, or we can put numbers as well to denote the angles, whichever is convenient to us. Now we will prove a theorem. The statement of the theorem is, if two lines intersect each other, then the vertically opposite angles are equal. So the given condition is two lines, let's say AB and CD, are intersecting each other at O. We need to prove the vertically opposite angles are equal. Let's denote the angles using numbers for convenience. We are representing angle AOD as angle 1, angle BOD as angle 2, angle BOC as angle 3, and angle AOC as angle 4. We need to prove angle AOD represented by 1 is equals to angle BOC represented by 3, and angle BOD represented by 2 equals to angle AOC represented by 4. That is, angle 1 equals to angle 3 and angle 2 equals to angle 4. In order to prove this, we will use the first three angles starting from whichever angle we want in clockwise or anti-clockwise direction, and we will take the linear pair property. That is, if we start with angle 1, we should go till angle 3, 1, 2, 3 or 1, 4, 3. If we start with 2, we should go till 4, angle 2, angle 3, angle 4, or angle 2, angle 1 and angle 4. We can do that in any order. So let's do it using angle 1, angle 2, angle 3. So first, over line AOB, if we will add angle 1 and angle 2, we will get it as 180 degree, as they are forming a linear pair of angles. We will put this as equation 1. Next, over line CD or COD, angle 2 and angle 3 are again forming a linear pair. So angle 2 plus angle 3 will again give us 180 degree. We will put this as equation 2. Now, equation 1 and equation 2 both are resulting in 180 degree. That means the left hand side of the equations must be equal. Since the right hand side is equal 180 degree and 180 degree, so the left hand side, angle 1 plus angle 2 should be equals to angle 2 plus angle 3. On comparing equation 1 and equation 2, we will get angle 1 plus angle 2 from equation 1 equals to angle 2 plus angle 3 from equation 2. Now since we have angle 2 common on either sides of equals to, we can cancel angle 2 from both sides of equal to, as they are common. So now we are left with angle 1 equals to angle 3. Similarly, we can prove that angle 2 equals to angle 4. Since the process is exactly the same, we don't need to show the process again. We can simply write, similarly, we can prove that angle 2 equals to angle 4. Hence, the proof is done. Now, work on the proof of this theorem on your own. Thank you and have a nice day.